So what it's like to be a blindsight patient, and one possibility is that the higher criterion for detection. But in summary of this, short video, criterion in blindsight has been studied a little bit, and at least the manipulation of stimulus frequency was tested, and there was a very small effects for stimulus frequency. So the critical task design is the following. Experiment 1 was that 60% in the intact hem field, very faint stimulus, and then 5% for the high contrast blind field and 35. But experiment 2 changed this proportion on the right side. So it's now 50-50 in terms of the contrast. When GY feels that there was nothing, 50% of a chance that he gets correct when he just says that, oh, I saw this over there. So if he loosen a little bit of the criterion, he could succeed in 50% of time. So what happens in this situation? Just to remind you, the task that we are talking about is the following. There is a 1, 2, 3, 4 alternative location for the intact location of the stimulus, and the fifth location is this blind field, and then the sixth option is that to report nothing. And then now the critical thing is that the 20% of the trials are nothing really on the display and nothing, and then the 20% of trials are actually presenting the stimulus, high contrast stimulus on the right side. It could be 30 or 46 or 99%. So to summarize the results so far, then both in experiment 1 or 2, as long as stimulus was presented in an intact field, then the GY was always correct, 100%. So that's this bar graph. And then 3 means the 3% contrast, and 60 means the 60% of the proportion of the trials were that. And then 0 means that the 0 stimulus, no stimulus, and that was presented in 35% of the trials in experiment 1 and 20% of the trials in experiment 2. And in this case, again, experiment 1 and 2, he was just correct, 100% correct rejection or 0% false alarm, okay? And then in the experiment 1, just to review, GY was like saying no for the case when the stimulus was on the blind field. That's true for 30% or 46% contrast stimuli. And then 99% stimulus, he said yes all the time. And in the case of experiment 2, they changed the proportion of this, blind field trials as 20%. So much more proportion of trials was blind stimulus. And then 30% stimulus was always, reported as nothing, and then 90% stimulus was presented as reported as always there. And then 46% stimulus starts to change a little bit. Okay, so he changed a little bit, but not much. That's the conclusion. So 30% situation and the 100%, 99% situation, the location of the data doesn't change. But in the case of 45%, there's a little bit of the hits, 0.15. So the ROC curve it's here. So in the case of a GY, for the 45% contrast stimulus, there is a possibility that the D prime is, or the visibility is above 0. It's consistent with D prime 1 or D prime 2 or D prime 3 and so on. But as long as false alarm is 0, it remains kind of unclear what it means. And 30% stimulus case, it also remains unclear from this particular experiment. So what can we conclude in summary? Even with the changes in the stimulus frequency, GY reported not seeing in most of the cases. And so you might at this point think about, okay, maybe we should motivate GUI better. And that's the kind of the situation we are going to talk about in the later lecture. So basically, is there any better way than the percent correct than or signal detection theory? And one way to do that is to combine the signal detection paradigm with the confidence to assess the accuracy of the so-called metacognitive access, how much they know and how much they can use their knowledge or seeing impression for their subsequent behavior. So that's what's coming in the next week. And then also we need to start thinking about not only this kind of behavior reports, phenomenology, and also behavior data. We need to understand the neural mechanism of the blind side. And to do that, we need to understand a little bit more about the visual system itself. I talked a little bit about the posterior visual cortex today, but starting from eye, how does the information gets to V1, the primary visual cortex, and so on, needs to be understood. And that's for the next week. See you.